So Pythagorean theorem can also be applied to some word problems. So if we think about the foot of a ladder placed 6 feet from the wall, the top of the ladder rests 8 feet up on the wall, how long is the ladder? Well, we have to draw a picture. So here's our building, here's our ground, and we're going to assume our building is straight. Here's our ladder. So the ladder is placed 6 feet from the wall. So that means that this distance right here is 6. The top of the ladder rests 8 feet up the wall. That means that we're reaching a height of 8. How long is the ladder? And that is opposite our hypotenuse, and so we're left with h squared is equal to 8 squared plus 6 squared. So when we do that, h squared is equal to 64 plus 36. H squared is 100, so h is 10 feet. The picture really makes it pretty clear. This has a twist. In the Old West, we had tents, like so. And a single piece of cloth could be used to make this tent, and we want to know how long that is. So it's an isosceles triangle, which means these two pieces make sense. Our tent needs to be square. How long would the cloth have to be? So the opening was 4 meters high and total of 3 meters. Well, our pole better be straight, which again, perpendicular bisector theorem means these two pieces are equal, which means this bottom piece is 1.5. So I'm really looking for this outside length of the right triangle, where that is our hypotenuse. So I've got L squared is equal to 4 squared plus 1.5 squared. When I work that math out, I get that L squared is equal to 18.25, and so L is 4.3. But I need to know how long the entire cloth is. And if this is 4.3 and this is 4.3, my total length would have to be 4.3 times 2, which would be 8.6 meters. So you always want to make sure that you're answering the question. Now, another interesting application for the Pythagorean theorem is as a test, a right triangle test. If the Pythagorean theorem is true, it's a right triangle. If it's not true, it's not a right triangle. And so that is the converse of the Pythagorean theorem. So longest side is 5. So if this is going to be a right triangle, 5 would have to be my hypotenuse. So let's check. If I square 5, will that be equal to 3 squared plus 4 squared? Is 25 equal to 9 plus 16? Yes. Therefore, right triangle, because this is a true statement. Now, square root of 5, square root of 3, square root of 8. The square root of 8 is a bigger number, so that is going to be my hypotenuse if this is indeed a right triangle. So the square root of 8 squared, is that equal to the square root of 3 squared plus the square root of 5 squared? Well, square root of something squared cancels, so is 8 equal to 3 plus 5? Yes, that's true. Therefore, right triangle. Now, 13 is my biggest side, so potential hypotenuse is 13 squared. Is that equal to 11 squared plus 5 squared? Is 169 equal to 121 plus 25? Well, 169 is not the same as 146. That is a false statement, therefore not right. And that's how you use the converse of the Pythagorean theorem to prove if something is or is not a right triangle. So the last video is going to get into the special right triangles.